Hello, everybody, and welcome back. Today we are going to be talking about the sine law. So, last time we talked about basic trig ratios, and while they're very great, very simple to use, there's lots of benefits, the one drawback is that basic trig ratios only work when we have a right angle triangle. And there's so many triangles that are not right angle triangles, but luckily for us, there is a way to use our basic trig ratios a little bit differently in order to determine um, the sides and angles for triangles that are not right angle triangles. So if a triangle is not a right angle triangle, or we don't know whether a triangle is or isn't a right angle triangle, we can use the sine law. So basically, the sine law states that if we have some triangle, any triangle, doesn't have to be a right angle triangle, it states that angle A, that sine of angle A over side A is equal to sine of angle B over B, which is equal to sine C over C. Now, typically, we wouldn't actually equate all these three and do a three-way equation. We would typically just choose the two that are relevant. Now, something else I want to point out that's very important is that the sides and angles are not just randomly decided, that the angle C is specifically opposite to the side C. Same thing with the other sides and angles, right? The angle B is specifically, the opposite of side B. And then same with A, right? We have angle A here. Side A is the opposite side from this angle. And so that's very key and very crucial that we ensure that that is the case. So, in English terms, what this law says is that the sine of an angle over the side is equal to the sine of another angle in the same triangle over that side. And so, as you can imagine, if we know any one side angle pairing, right? If we know, for example, what angle B is and what side B is, and we know one of the other ones, then we can solve for something new, right? In that case, we only have one unknown and we can solve for something new. Now, we're not going to have the right amount of information in all situations. There are a couple situations where we won't be able to use this law, and we'll go over those in the cosine law video. Because in cosine law, it covers a couple cases that the sine law doesn't, but it's a lot longer and more complex than the sine law. And so we only usually use cosine law if we absolutely have to in those two cases. But in other cases that are not those two cases, we're able to use sine law. And that's the way we like it, if we can get away with that, because it's a lot simpler. Okay, so let's do an example. Here it says to find x. So let's figure out what is given to us. So we are given an angle and a corresponding side. That's the opposite of that angle. We're given angle B and side B, which is good. It's a great start. We're also given angle C, and we're expected to find side C, which is x, right? The side opposite to angle C is the side C, which in this case is x. So I'm going to write down the second half of this formula, which is that sine B over B is equal to sine C over side C. Now I'm going to plug in my numbers. I'm going to say, well, sine B, well, that's the same as sine 54 degrees over 6. Sine C, well, that's sine of 84 degrees over side C, which is equal to x. Now I'm going to cross multiply and change some things around in order to get this to be x equals blah, blah, blah. So x is equal to 6 sine 84 over sine 54. So what did I do here exactly? I took the x up, I put the sine 54 down, so I swapped these two. I also put the 6 up, right, because I wanted to solve for x specifically. Now I'm going to grab my calculator, and I'm going to punch into my calculator 6 times sine 84 equals, and then divide that answer by sine 54, press equals again, and I ended up with x is equal to 7.375, which I'm just going to say 38. I'm going to round to 2 decimal places for these examples. And there's my answer. There we go. So you can see how we realized that we had a side angle combination, and we also had the angle that we needed to find the side that they were looking for. And so we were able to use the sine law here and apply it in order to solve this question, which is fantastic. All right, let's try another example. This one says solve for angle C. So what do we have? What are we given? We're given a side angle pairing. We're given 40 and 12, right? And then we're given 10, and we're asked to find the angle C, right? We're asked to find this angle over here. So let's do it. We know that sine A over side A is equal to sine C over C. So let's now plug in our answers. So we don't know what sine C is. We're trying to solve for C. We know that side C is 10, right? Our opposite is 10. And we know that sine A is sine 40. And we know that our side A is 12. So now I'm going to just move this 10 up so that I can get sine C is equal to 10 sine 40 over 12. Now I'm going to simplify my right a bit further. I'm going to type into my calculator 10 times sine 40 equals divided by 12 equals. And that is 0.535656, etc., right? So I'm just going to leave it, I'll leave it like that. But it's actually 535656341, and then some other stuff probably as well. And what am I going to do to find C, right? Because again, I don't want to know what sine C is. I would like to know what C is. I'm going to take this number. I'm going to press second function sine, which is going to give us the inverse. And that is going to get me that C is equal to 32.388 degrees. Now, since it's degrees, I'm just going to round to the nearest degree and say it's equal to 32 degrees. So if you're unsure how to do that, I'm going to repeat again that after we find this number, 0.5375, you're going to press the second function button or the shift button on some calculators, and then press the sine button, because shift sine or second function sine will get you the inverse sine, and that's what we would like, right? Because essentially what we're doing here is we're inversing sine on both sides in order to isolate C, because we want to get rid of this sine and figure out what is our angle C. So the answer is 32 degrees. Awesome, amazing. Now let's do example 3, and then that will be it for today, as next day we'll talk about the cosine law. That's another topic. This one says a bridge AB is built across a river. Point C is located 61 meters from point B. Angle ABC is 68.5 degrees, and angle ACB is 42 degrees. How long will the bridge be? So for this kind of question, this is a word problem. And so first I'm going to draw a picture. So let's just draw a picture. I'm not sure how to scale the picture is going to actually be, but that is okay. That is, not the point of the picture. The point of the picture is to help us visualize where everything is. So let's say this is point A, point B, and point C. And so this is our bridge. I'll kind of make this look more like a bridge a little bit. I'm not going to draw a great bridge, but there you go. There's my bridge. And it says that point C is located 61 meters from point B. So that means this is 61 meters right here. We also know that angle ABC, which is really angle B, right here, is 68.5 degrees. And we know that angle ACB, so angle C here, is 42 degrees. And we're being asked, how long will the bridge be? So in this situation, there's something quick we can figure out. because it looks like we don't have enough information to solve this unless we realize this. So there is a property that states that all three sides, or sorry, all three angles of any triangle, whether it's a right triangle, whether it's a different triangle, always add up to 180. So in order to find angle A here, all I must do to find angle A, or in their terms, angle CAB or BAC, doesn't matter. This is equal to 180 minus 68.5 minus 42. And that's equal to 69.5 degrees. So there we go. So this is 69.5 degrees. So now that we have that, we can actually apply the sine law here. We can say, well, what are we looking for? We're looking for side C, or in other words, the side that starts at A, ends at B, that is opposite to C. That's what we're looking for. And we have the angle is 42 degrees. We also have 69.5 degrees, which we just solved really quick, and that 61 is our opposite there. So we are able to use the sine law to say that sine of angle A over side A is equal to sine C over side C. Voila. So that means sine 69.5 over 61 is equal to sine 42 over C. So again, now we're going to cross multiply. We'll get that C up to the left, and we're going to put the sine 69.5 down to the right, and the 61 up to the right. So we're going to end up with C is equal to sine 42 over sine 69.5, and then 61 goes up here. And then in my calculator, I'm going to grab it. I'm going to type in 61 times sine 42 equals divided by sine 69.5 equals. And this is 43.576. Okay, so that's 43.58 if we're rounding to two decimal places, which is what I'll do today. So therefore, the bridge will be approximately 43.58 meters. And actually, this is a word problem, so I will give a conclusion statement. The bridge will be 43.58 meters. So as you can see, my drawing wasn't really that to scale, but again, doesn't really matter very much at all. Well, what matters is that we were able to visualize where A, B, and C were relative to one another so that we could apply the sine law so that we could solve the question. So that's the important part. All right, well, good work today, everyone. I will see everybody next time to talk about sine law, which is our next topic. Have a great rest of your day, and we will see you then. Bye for now.